Hello everyone, my name is Tatiana Litvinova and I'm head of Corpus Idiolect Research Laboratory, Voronezh Pedagogical University, Russia. So in today's talk, I'm going to address a very important issue of idiolect identification in cross-genre and multi-genre scenarios using approach from bioinformatics. Authorship attribution is the problem of attributing a text to its author, which is a task of considerable practical importance. There has been a huge increase in the number of papers published on this issue in the last 3 years. Lately, this problem has been tackled mostly as one of the task classification problems and one of the subtasks of user identification problem. Different types of linguistics markers have been used as features, word and part of speech statistics, text length, etc. Despite 1.5 century of research efforts, identification of an idiolect based on quantifiable linguistic features remains a challenging task in practice. The complexity of the task increases when training documents and documents in question differ in topic and/or genre, albeit this scenario is not uncommon in forensic settings, where a small size of training corpus is typical. To address this type of idiolect identification problem, use of corpus approach is crucial. Namely, a corpus of multiple tags per author is needed. The tags should represent author's idiolect in various ways. So tags should differ in topic, genre, mode, written, oral, type, way of production, handwritten, typed, or in physical or touchscreen keyboard, etc. The authorship of all the tags in such a corpus should be unquestionable. In addition, data on author demographics, education, etc. should be available to make the results of experiments in idiolect identification more interpretable. A team of Corpus Idiolectology Lab has collected the first freely available resource of this type, Rus Idio Style, which is now a part of Rus Idiolect database. Rus Idiolect has metadata related to both tags and author. 3 datasets were derived from Rus Idio Style, with each of them containing tags by 4 different authors. Each author's idiolect was represented by 4 genres: picture description, essay, narrative, tell the story that happened to you, description of the day, describe how you spent the day before the experiment. To compare the effectiveness of the models in different conditions, we divided the general dataset into 3 datasets of 4 authors each. The first dataset included the tags of 2 authors who are similar in age, education, and occupation, so those professionally working with tags, translators, and 2 authors of the same age group, whose professional activity is not related to tags. This dataset contains tags that differ significantly in length. We name this dataset contrasted. The second dataset consists mainly of tags of people professionally working in the field in one way or another related to tags: translation, editing, computational linguistics, but with different levels of work experience. So, starting from a student and ending with an editor with 15 years of experience. The authors are women between the age of 20 and 36. We call this dataset professional. The third dataset includes attacks by students as well as people with higher education whose activities were not related to attacks. We name this dataset non-professional. So here is general information on the attacks. So you can see the number of the dataset on all four sets, so contrasted, professional, and non-professional. The total volume in tokens, the average length and standard deviations in tokens and the median, the total number of tags, the average number of tags per offer, and standard deviation. Two scenarios of idiolect identification were constructed. First one is multi-genre. So both training and test sets were compiled from tags of four genres. 75% of the tags selected at random were training ones, the remaining 25% test ones. Both in the training and the test set, they were tags of different genres, which explains the name of the scenario. The test set included tags of the same genres as in the training set. So in both training and test sets, we have usual ordinary tags which represent all of our genres. The second scenario is cross-genre. So the classifier was trained on picture descriptions, stories, essays, and tested on the description of the day. This division into genres was caused by the fact that in all types of analysis for all datasets in which the influence of the genre was present, the tags, descriptions of the day, were opposed to the tags of other genres. Thus, by selecting as test tags descriptions of the day, we made this scenario as complicated as possible, which is considered to be the most difficult and challenging task in the modern literature on idiolect identification. There are features that are extracted using software in order to increase the objectivity of the research results. The most frequent tokens of the corpus, including punctuation marks, various threshold values were tested, which are in the range of 10–25% of the data set tags. Most frequent common corpus lemmas, trigrams, and tetragrams of symbols, various sets were tested, with an occurrence in at least 10–25% of tags. Trigrams of morphological tags, short form information about part of speech only, and punctuation marks. Full morphological tags, unigrams. Trigrams, which were named flow, word forms were replaced with words, punctuation marks of the end of the sentence were replaced with sound, others with punct, and signs of lexical diversity and readability. So they were used separately to test the efficiency of each type of the features. A new methodology is introduced in authorship identification research. As an analytical tool, methods for multivariate data analysis as implemented in our package Mixomics were used, namely PCA for assessing the main source of variation and its supervised version, PLSDE, used as classifier. We also used multi-level PCA for eliminating the effect of genre. Fourfold according to the number of classes, cross-validation with the number of repetitions of 25 was used. So 100 models were built in the training process. The accuracy of the model, number of correctly attributed tags, was evaluated on a test set, 25% of tags. The significance of the classification was evaluated using a permutation test. In addition, the probability of assigning a text to a class was calculated. Mixomics was developed for omics studies, which are characterized by multicollinearity of predictors, a large number of predictors as compared to that of the samples, and need for explanation, so finding the most discriminating features. The same is true for idiolectal studies. Another advantage of mixomics, which made it widely applicable in omics studies, is the rich possibility of visualization of the results. Using the above methodology, it was shown that the genre was the major source of variation for most types of the features, despite the general claim about their independence of the context, with the description being opposite to other genres. Multi-level PCA genre effect elimination leads to offer-based clustering for some offers, but not for all. Here we can see the clusters of tags by offer more visible in 3D graph. Mixomics provides users with a lot of possibilities for visualization. For example, heat maps are based on a hierarchical clustering simultaneously applied on the rows and the columns of a real-valued similarity matrix. This similarity matrix is obtained via the results of PLCDA. The matrix is graphically represented as a two-dimensional colored image, where each entry of the matrix is colored on the basis of its value, and where the rows and columns are reordered according to a hierarchical clustering. Dendrograms resulting from the clustering are added to the left or right side and to the top or bottom of the image. Variable importance in projection, VIP coefficients reflect the relative importance of each x variable for each x variate in the prediction model. VIP coefficients thus represent the importance of each x variable in fitting both the x and y variates, since the y variates are predicted from the x variates. For all the datasets and both scenarios, the accuracies of idiolect identification higher than the baselines were obtained. The significance of the results was tested. Albeit the importance of the classifiers differed with respect to the datasets, as well as the most efficient features. As for the discussion section, so it should be said that obviously there are no context-independent features, so that's basically a myth. And then eliminating genre effect does not really result in the increase in the overall accuracy. And all offers are unique in their own ways, and the way they interact with various situations varies. Cross-genre scenario is the hardest one, but meaningful results can be obtained. Different features are useful in different scenarios and even for a variety of datasets, so no silver bullet. And some offers are more recognizable than others. On top of that, experimental results have shown that the cross-genre scenario is more complex than mixed. But all groups of features, except for features of lexical diversity and readability in the professional dataset, yield a statistically significant result even in such a scenario. Note the particularly high accuracy of the classifier, built on complete morphological tags in this scenario. This group of features, rarely used in stellometric identification studies, is presented as very promising and in need of further research. We also note the high efficiency of using the most frequent lemmas and features of the POS punct group in the mix scenario. Stably high, no less than 0.7 accuracy in different scenarios for all analyzed datasets gives a set of features of the n-gram. So as for directions of future work, so what needs to be done is that we must obviously get more data sets to work on, then more scenarios are needed to investigate deeper and more profoundly. And then finally, more features are also essential. So, including process oriented based on the text production in real time. So here you can see some information about our references and funding details. So thank you all for your attention. Me and members of my team will be absolutely happy and excited to hear your feedback on our ongoing project, and will also be very happy to share the details of some of our previous, current, and future projects, and we will be very happy to hear any type of input. So, thank you very much and have a wonderful day. Thank you.